This is Thales. Little is known about him, but mainly what we know is from philosophers and record books that they have on him. He was said to be the first philosopher and first scientist of his time. We're going to talk about the 5 contributions that he made and go into little detail about each one. So the first contribution that Thales had was an angle inscribed in a semicircle is a right angle. We'll talk about each one individually later, but first we're just going to cover each topic. The second one is a circle is bisected by its diameter. The third theory is the pairs of vertical angles formed by 2 intersecting lines are equal. The fourth theory was that the base angles of an isosceles triangle are equal. The fifth theory is that if 2 triangles are such that 2 angles and a side of one are equal, respectively, then 2 angles and a side of the other, then the triangles are congruent. So we'll be back in just a moment to go over each one separately. So now we're going to get started with the first contribution he made, and we're going to do a good example of it. So it says that any angle inscribed in a semicircle such that A or B is in the figure is a right angle. So I'm going to go ahead and draw that. So we have a circle. Okay, and then we have point A and point B. And now I'm going to form the right angles. So now I'm connecting point A to the line, point B to the line, and now I'm going to connect the opposites to form the right angle. So now, as you can see, we have a right angle here and a right angle here. So an angle inscribed in a semicircle, which this is creating the semicircle, is a right angle formed right there at A and B. Our second contribution by Thales was a circle is bisected by its diameter. So we're going to explain that right now. You have a circle right here. And then a diameter of a circle is any straight line of a segment that passes through the center of the circle and whose endpoints lie on the circle. So here's roughly the center of the circle, and here are my endpoints that lie on the circle. And I'm going to connect the lines to form the diameter. And what Thales said was that this diameter bisects it, so this half is equal to this half. And that is the second theory. The next theory we're going to talk about is the pairs of vertical angles formed by 2 intersecting lines are equal. So this theorem is known as the intercept theorem, and it's known as the Thales theorem. It's an important theorem in elementary geometry about the ratios of various line segments that are created if 2 intersecting lines are intersected by a pair of parallels, and that is shown by this figure right here. So with that being said, it is going to demonstrate, and I'll write this a little bigger, that DE, which is right here, is proportionate to BC, then AE, right here, is proportionate to AC, and AD, right here, is proportionate to AB. So the pairs of vertical lines of the angles formed by 2 intersecting lines are equal, and they're all proportionate to each other. Since all the sides fall into proportion, then we can say that the vertical angles formed are equal. So we have a vertical angle here, and here, here, and here, here, and here. And they really go anywhere along the intersecting line. So that's how they are equal, because we know that all of the sides are proportionate in a ratio, and so that is why Thales' theorem is valid. Thales' fourth theory was that the base angles in an isosceles triangle are equal. So first I'm going to start out by drawing an isosceles triangle, which means that 2 sides are equal. So I'm going to draw 2 inch on each side. And then connect it at the bottom, and it doesn't matter how long the bottom one is. So now we have that this side and this side are congruent. So what Thales said was that isosceles triangles, the base angles, which are down here, are congruent because if these side lengths are the same, then their base angles are going to be congruent as well. The last and final theorem says, if two triangles are such that two angles and a side of one are equal respectively to two angles and a side of the other, then the triangles are congruent. So we have our first triangle right here, which I'm going to call triangle A, and then we have triangle B. So what his theorem says is that if two angles are congruent, which we have these two right here, and one side, therefore these two triangles will be congruent. And that is the end of all of his theorems.